Hello everyone, welcome to my U programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is peak index in a mountain array. So the challenge statement is like this: an array ARR, a mountain in the following properties hold. Array is a mountain if the following properties hold. Length of the array is greater than equal to 3. There exists some index I such that it lies between 0 to array length minus 1. So the thing here to be noted is that the 0th index and the array length minus 1th index are not included, and all of the indices before the till the ith index are in increasing order, and after the ith index all of the elements are in decreasing order. So given a mountain array, return the index I such that these conditions satisfy. This is what the both conditions are written at the same place. So as you can see, till the ith index it's increasing, then after the ith index it's decreasing. So what's the program statement is saying? Let's say this is the peak index or the ith index, and this is peak. So this is 0 and this is array length minus 1 index. So till this ith index the trend is like this, and after that the trend is like this. So this ith index forms the peak. So I hope it's clear to you. Then it's given that you must solve this challenge or the problem in O of log n time complexity. So the length of the array is of the order 10 raised to power 5, and the elements are between 0 to 10 raised to power 6, and array is guaranteed to be a mountain array. So how we will be able to solve this problem? Here the brute force way of just iterating the array only once. If you decide to iterate the array, let's say iterate the array, iterative approach, which is the brute force approach here. So if you decide to iterate the array only once, then the time complexity will be O of n, but you are asked for O of log n time complexity. Here n is the size of array. So how to achieve this time complexity? If you carefully observe, let's say if you are at this index, let me quickly change the color. Let's say this is the index you are at, and this index, let's say, is x index, and if you know that the x plus 1th index is lesser than the x index, then you already know that you are in this region, you are in the declining region. And if you, let's say x, you are here at the yth index, and if you see that the y plus th index element is greater than the yth index element, then you know that you are in the increasing region. So by these checks you would be able to know in which region you are in. So depending on in which region you are in, you can reduce the search space in half. How will you, depending upon, let me quickly change the color again, depending upon which region you are in, you can reduce the search space in half. How will we able to reduce the search space in half? Let's say we took two variables. Let me quickly move to a new slide. And our problem was like this. This was the peak. It was the 0th index and it was the array dot length minus 1th index. This is the 0th index. So if you take two variables, let's say this is left and let's say this one is right. Now left is pointing to the 0th index and right is pointing to the array length minus 1th index. So depending upon in which region you are in, you can reduce this search space from left to right. What you will do is you will find a index between left and right, which is mid, which will be left plus right divided by 2. So if this newly found mid satisfies this condition, which condition? This condition. If mid index element is greater than the mid plus 1th index element, then we are in this region. What I am saying is, if mid array of mid is greater than array of mid plus 1, then we are in this region and we have to go, let me quickly change the color again. We have to go this way because this is the declining part. To go to the peak, we have to go upward. So what we'll do, we'll change our maximum bound, this right index, we'll decrease it. What we'll do, right will be now equal to mid minus 1. Since this index, let's say it was mid, it was in the declining part, then we'll form our new max bound here before this index. It will be new right, or say max bound of range. Similarly, we will do for the left side. If mid happens to be here, let's say here, and the conditions hold like this: if mid is lesser than array of mid plus 1, then we will simply go in upward direction. Let's say this was mid, then we will move our lower bound to mid plus 1. Our lower bound left will be moved to mid plus 1. So that's pretty much it, and we'll continue this as long as left is less than or equal to right, till there is one remaining element in our range. So yeah, that's pretty much it. And when we'll be storing the peak index, since here in this condition, when mid was greater than mid plus 1, for these two, if these two were to form a array, let's say there was something before mid, let's say there was mid minus 1, then in that case the mid would have been a new peak. So when we are encountering this condition, we will store the peak's value to be mid, and then we will reduce our upper bound of the or maximum bound of the range. Now let's move towards the coding part. There you will get a more clearer picture how we will be implementing this algo. And also, since we are asked to implement in O of log n time, since we are dividing search space in half each time, then our time complexity will be order of log n. And this technique is called binary search. Those of you who are new to binary search, I'll be providing a link for it. A link will be provided for our article describing binary search, and you can read this article and get a more clear understanding of binary search. Anyways, I have not completely left up to you to discover binary search. I have given you the idea how it works for this kind of problems. You should also read about binary search if you are new to it. Now let's move towards the coding part. Let me quickly zoom out. Yeah. So what we have done is we have initialized left pointer to 0 and right to array of length or size -1. And currently our peak is pointing to nothing, so I have made it to point -1. You can make it to point whichever you may choose. And anyways, we will be updating our peak at least once, since there are 3 elements. So the mid is calculated in a somewhat different way. This is to prevent integer overflow. Now how we are preventing overflow? There might be a case if right is the maximum value, let's say it is the maximum value that a int can handle, and left is the minimum value a int can handle. So in that case, it will not be able to be stored in this variable. So if the both of them are pointing to the maximum values, then it will not be able to store them in a int variable. So to prevent the overflow in a int variable, we have taken this condition. You can here the constraints are not that much lengthier. Array of size is of the order array of element sizes of the order 10 to power 6. So you can also take right plus left divided by 2. It's essentially the same thing if you expand it. For example, let's see, it's left plus right minus left plus 2. So if we expand it, it will be twice of left plus right minus left by 2. So one left and left will cancel out. Left plus right it will be, and divided by 2. So it's the same thing. Then according to our condition, we will be updating this happens if we are in decreasing part. And this happens if we are in increasing part. Then if we are in decreasing part, mid will be current peak, and will decrease lower bound or upper limit of the range, else will increase the lower limit of the range. Range here is search space, or say indices. Pardon me if some spelling is incorrect. I hope you are able to understand. So yeah, this wraps up the problem solution. So thanks for watching. Thank you.